Hello, welcome back to my channel. In today's video, we will cover 5 key topics that are essential for preparing and modeling data in Python. First, partitioning the data. Partitioning is essential in presenting the data for training and evaluation. The data is divided into a training set where the model learns patterns and a test set where its performance is evaluated. Typically, the division is random using proportions like 70-30 or 75 to 25 depending on data set, size and complexity. Cross-validation ensures results are generalizable. Why do we do this? Well, it helps ensure our model performs well on unseen data. Here's how we do it. Here how we do it in Python. Import the following packages. Import pandas. Import sklearn.model selection. Import random. Read dataset. To partition the dataset, we will use command train test split bank train comma bank test equals to train test split bracket bank comma test size equals to 0.25 random state equals to 7. The command creates two dataset bank train and bank test while the name of the dataset are arbitrary. The test dataset is always the second one created. The first input bank specifies that we are partitioning the bank dataset and test size 0.25 input states that 25% of the bank dataset should be in the test data set, while the remaining 75% should be in the training data set. The random state input set the seed for the random number generator that will randomly split the data into training and test data set. The first number given from the bank train dot shape and bank test shape. To confirm that the data set was partitioned correctly, you can compare the shape of the original training and test data set using the shape features. Now, let's talk about balancing the training data set. This step is crucial for dealing with imbalanced data set. Balancing ensures that all classes of the target variable are adequately represented. Crucial in cases of class imbalance, for example, fraud detection. First, we identify how many records in bank train have the less common value using value count method. Bank train response dot value count. Resampling is often used to balance data sets, either by oversampling the minority class or undersampling the majority class. To resample equals to bank train dot LOC bank train response equals to yes. The LOC command subsets the bank train data based on the condition bank train response equals to yes and saves the resulting data set under the name to resample. We need to sample from our record of interest. Our sample equals to 2 resample dot sample and equals to 841 comma replace equals to true. The sample command draws record at random from 2 resample which holds the record we want to resample. Finally, we add the resampled record to our original training data set. Banktrain rebel equals to pd dot concat banktrain, comma, our resampling. The concat command attaches two data sets by putting the rows on top of each other. The result is a single data set made up of the record in both Banktrain and our resamples, which is saved as its own data set under the name Banktrain Rebel. Rebel. Now, how to build card decision tree? What is card decision tree? Card decision trees, short for classification and regression trees. Card splits data based on features using matrices like the Gini index to measure purity. What is Gini index? The Gini index is a measure of impurity or diversity in a data set. It ranges from 0, which means pure, where all instances belong to one class, to zero point 0.5, which means maximum impurity, where classes are evenly distributed. A lower Gini index indicates a better split when building decision tree. This is the code from sklearn.tree import decision tree classifier. From sklearn.matrices import classification report. Card model equals to decision tree classifier criteria Gini, comma, random state 42. Card model dot fit xtrain, comma, ytrain, y PRED equals to card model dot predict x test, print classification report, y test, comma, y PRED. How to build C5.0 decision tree using Python. These are an improvement over card using entropy to measure information gain. What is entropy? Entropy measures the level of disorder or uncertainty in a dataset. It is 0 when all data belongs to a single class, which means pure, and higher when data is evenly spread across classes. In decision trees, entropy helps identify splits that reduce uncertainty the most. Information gain. Information gain measures how much a split on a specific feature improves the purity of the target variable in a dataset. It calculates the reduction in uncertainty or disorder after dividing the data, helping decision trees choosing the best feature to split at each step. This is the code for C5.0 decision tree. And finally, random forest. These are examples of decision trees combining the power of multiple trees for better performance. Each tree is trained on a random subset of the data and the predictions are aggregated for the final input. This is the code for random forest. Random forest. From sklearn.ensemble import random forest classifier. From sklearn.matrices import accuracy score. These libraries we are using to build random forest. Thank you. If you have any doubt, please comment it down below. Don't forget to like, subscribe and share.